Day 110 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. But you guys knew we would be back. You knew we weren't going anywhere, and you knew we're staying disciplined and we're staying consistent. So I don't know why you're surprised. I'm not surprised. I already knew we were going to be here. Day 110, and we're still going strong, y'all. So I hope y'all are staying motivated, and I hope y'all are staying consistent because we're just getting started, and we have a lot more to learn. But before we get started today, y'all, don't forget, bring your mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. Then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we can run up this engagement and we could help get this content out to a broader audience and do our part in helping the Swift community grow as a whole, y'all. So we're all working together here. We're all part of the Swift community. We're all here to encourage each other and to motivate each other, to lift each other up, to keep going, y'all. So go ahead and smash that like button and drop some in the comments for me if you haven't already, and the subscribe button too. Now, before we get started, now it's time to get started, y'all. And I know why y'all here. Today we have question number 3065, minimum operations to exceed threshold value. The difficulty level is easy, so you already know how we do on this channel. We're going to keep the solution as simple and easy to understand as well, because we're all trying to learn here. And there's no point in writing code that nobody can understand. That goes for if you're writing your own project or you're at work. Nobody wants to read code. Nobody wants to come after you and have to read code that's difficult to understand. So we're going to keep the solution simple and easy to understand as well. So let's see what the question says. It says you are given a 0-index integer array nums and an integer k. In one operation, you can remove the one occurrence of the smallest element of nums. Return the minimum number of operations needed so that all elements of the array are greater than or equal to k. So let's look at the examples. So break that down and see what they're really talking about. But it's not that difficult at all, y'all. And we've actually done a problem like this before. So let's see. We have example 1. We have the input nums. It's an array of integers 2, 11, 10, 1, and 3, and k equals 10. The output is 3. The explanation says after one operation, nums becomes equal to 2, 11, 10, and 3. So it becomes equal to that because we removed this 1, which is less than 10. That was the first operation we did to remove the number smaller than k. So what we're trying to do is we're removing all numbers smaller than k, but we can only do it one at a time. And we want to count how many times we do that, right? So let's see. So first we're going to remove the 1 because that's less than k, right? Then after 2 operations, the nums becomes equal to 11, 10, and 3 because that means we remove the 2. Now it's been 2 operations. First operation, we move the 1. Second operation, we move the 2. The goal is to remove all the operations that are less than k, which is equal to 10. And right now we've done 2 operations. We removed the 1 and we removed the 2. Now, after 3 operations, nums becomes equal to 11 and 10. So we perform a third operation. So now we've done 3 operations. We've removed the 1, we've removed the 2, and we've removed the 3. All of them because they are less than k, which is 10 in this case, right? So at this stage, all of the elements of nums are greater than or equal to 10, so we can stop. So after we remove these 3 elements, the 1, 2, and the 3, now we're just left with the 10 and 11, and both of those are equal to or greater than k. So we can stop right there. Then it says it can be shown that 3 is the minimum number of operations needed so that all elements of the array are greater than or equal to 10. So we had to perform 3 operations to remove these 3 elements, right? Because they're all less than equal to k. They're all less than k, so we removed all of them. And that took 3 operations. That's why the output is 3. Another way of looking at it is how many numbers how many numbers are there in the array that are less than k? Boom, there's 3 numbers that are less than k, so that means we will have to perform 3 operations. So the output is 3. Let's look at example 2 so we can really bring this home, make it make sense for everybody. So we have input nums 1, 1, 2, 4, 9. This time k equals 1, and the output is 0 because all elements of the array are greater than or equal to 1. So we do not need to apply any operations to nums. So since all of these operations are already greater than or equal to k, we don't have to remove anything because they're already greater than or equal to, and we just want to remove the ones that are less than k. So let's look at example 3. Last one, we have an input nums, an array of integers, 1, 1, 2, 4, and 9. K equals 9. This time the output is 4. It says only a single element of nums is greater than or equal to 9. So we need to apply the operation 4 times. So we remove this one because it's less than 9. That's one operation. Then we remove this one because it's less than 9. That's another operation. Then we remove this one, this 2 because it's less than 9. That's 3 operations. Then we remove this 4 because it's less than 9. And altogether, that's 4 elements that are less than 9. And that's 4 operations that we had to do to uh, return this output. So now that we understand what the question is asking, let's get into the code. And the code is not that difficult, y'all, so get excited about that. And guess what, y'all? Guess what? Yep, you guessed it. We got a one-liner. So we can finish this in one line of code. That's how not difficult it is and how easy to understand it is. And to do that, the first thing we are going to do, we're going to say nums. Then we're going to say dot filter. We've done a problem like this before, so if you've been keeping up with the channel, you should already know what we're going to do. We're going to say nums.filter, then we're going to open up the brackets, we're going to say $0. Now, if you're new to this channel and you don't know what $0 is, $0 basically it represents each element in the array. So then, now that we put the $0, we're going to put the less than sign, and then we're going to put k. So this is going to filter out each element. This is each element that is less than k. So it's going to filter all the elements out that are less than k. Those are the ones we want to remove. Then we're going to say dot count, and it's just going to give us a count of how many elements it just had to filter out that were less than k. Because it's the number of elements that are less than k is equal to the number of operations that we're going to have to use. So that's why that works like that. So now that we understand the code, let's run it, make sure it works, make sure there's no bugs, pesky bugs or typos or anything of that nature. And it's accepted, y'all. That's what I like to see. So let's run it, make sure it stays submitted, make sure it's all good. And there it is, y'all. 12 milliseconds beats 65% of users with Swift, y'all. Not too bad at all, y'all. So get one more look at the code. I hope y'all learned something today, and I hope to see y'all tomorrow for another day, another LeetCode problem. Peace.